Welcome. This is chapter 5, carbohydrates. We're moving right along. So, we're going to be dividing up this chapter into two segments. This first segment, we will be talking about what are carbohydrates, identifying the major types of carbohydrates, how they are digested, the differences between the different types of sugars, what is involved in glucose metabolism. The second part is going to be specifically about diabetes and some of the, um, well, mainly about diabetes and some of the um, different types of dietary recommendations surrounded around diabetes, talking about increasing your fiber intake or metabolic syndrome, and kind of pathologies around carbohydrates. But so let's begin. If you remember way back in chapter 1, carbohydrates are one of the major macronutrients that were introduced way back in chapter 1. So carbohydrates are sugar, pretty much. They are substances that the body uses for energy. There are many different types. Glucose is the primary source of energy, or can be. The body does utilize glucose very well. It is used to make ATP, the energy needed in all of your cells for basic metabolic action, cellular respiration, that kind of thing. It is essential. Okay. But your body can also make glucose. And we'll be talking about that, how it is made or can be made through stored forms of energy known as glucagon, or excuse me, glycogen, glycogen. So glucose is a primary source of energy for the body, and it is the most simple. Okay, there are carbohydrates are grouped into two major categories. You have simple carbohydrates, and then you have complex carbohydrates, which get further broken down into starches and fibers and other types of complex. We also have your high fructose corn syrup, which we'll be talking a little bit more about later on, and your other types of forms of carbohydrates. So, carbohydrates are simply, or plants have carbohydrates in the form of starch. Plants use the sun's energy to combine carbon, oxygen, and hydrogen atoms to make carbohydrate. Plants can use their glucose to make fiber, starches, and other types of sugars. When we look at the different types of sugars, when we look at your simple carbohydrates, your simple sugars, the simplest form is what we call monosaccharides. Mono meaning one, saccharide meaning sugar. So there are three types of these monosaccharides, which we'll get to in a minute. Then you have disaccharides, you have three major forms of those, and then we'll build onto that. So let's begin by talking about your monosaccharides. So these are the simplest form, okay, of your simple carbs, and you have glucose, fructose, and galactose. So when you mainly think of sugar, or people often think of glucose, often referred to as blood sugar, or high blood glucose. And your body does like to use glucose as its energy. And you see the chemical makeup here, how it includes carbon, hydrogen, and oxygen. Okay. And glucose is one of the three types of simple sugars. I want to make sure you understand also this suffix "ose" means sugar. Okay, so you have glucose, fructose, galactose, maltose, sucrose, lactose. So anytime you see that suffix ose, it's going to mean sugar, a type of simple sugar. Fructose is the second type of monosaccharide known as your fruit sugar. It's naturally found in fruits. And then you have galactose, okay, which is the simple sugar formed in, or that is in lactose. When you take two monosaccharides and join them together, then you have what's known as a disaccharide, with di meaning two, okay? So you have two glucose molecules put together. That gives you maltose or malt sugar. So they're chemically combined. These are two simple monosaccharides chemically combined. And the reason why well, and because of this chemical bond, you through digestion, you need an enzyme in order to break these down, okay, in order to break it down into its simplest form. So we'll talk a little bit more about that here in a minute. The second type of disaccharide is your sucrose. So this is a monoglucose and a monofructose chemically combined to form what's now known as sucrose. And you are familiar with it as just regular table sugar, okay? And then we have lactose, which is the monosaccharide galactose and a monosaccharide glucose. When you put these two together, that forms lactose, and it is known as milk sugar. You see this chemical bond here, and some people do not have the enzyme needed to break this bond. So remember, they're chemically joined as a disaccharide, and you need an enzyme within the digestive system to be able to break it down into its simplest monosaccharide form. Some people do not have that enzyme that breaks down this lactose bond. So they end up with what's known as lactose intolerance. And it varies from person to person, but they need to take that supplemental enzyme sometimes in order to be able to tolerate milk. When we look closer at sucrose, okay, which is a type of disaccharide, it does naturally occur in nature or in our foods. Honey, syrup, maple syrup, carrots, your pineapples, a lot of your vegetable crops as well, such as your sugar cane and beet sugars here. It is sold as the table sugar that you might be most familiar with is white granulated sugar. And your textbook does give a very good comparison chart here that I would recommend that you look at that explains or compares the different types of sugars here. You also have what's called nutritive sweeteners, and that term nutritive simply means that they have calories or they have energy. So when we look at calories in, we understand that your nutritive sweeteners, your monosaccharides and your disaccharides, do have energy, and we quantify that energy through kilocalories, and there are 4 calories per gram of carbohydrate. Okay, 4 calories per gram. That's going to come up later on in some of your case studies, and it's going to come up later on when we start looking at food labels. You also have on food labels this category called added sugars. These are sugars that are added during the food preparation or food manufacturing process to, simply add flavor, right? Sugar is highly, don't really want to use the term addictive, but it is. It's It is very um, easy to crave sugars. The more you have, the more you want. And food manufacturers know how to make a food taste good by adding sugar. And what really alarms a lot of my nutrition patients when I was in clinical practice as a registered dietitian, um, I had even a more extensive list than this that I would go through with my patients or go over with my patients to help them to understand that sugars are not just called sugars and they're not just called added sugar. They have a lot of hidden names. So anytime you see anything ending in ose or an all or a syrup or have the word sugar in it, it's going to be sugar. Okay. And there's even more than this. There's even a higher, more extensive list than this, but I wanted to, your textbook did a good job with this in talking about some of the hidden names of sugar that we need to really watch out for on the food labels. There's also another category of nutritive sweeteners. Remember, nutritive meaning it has energy, meaning it has calories. But these are what we call sugar alcohols, meaning they are poorly absorbed in the gut. They uh, only about half of the calories can, or half of the sweeteners can be digested at a time or be absorbed because it's very difficult for your gut to absorb these sugar alcohols. So you have sugar alcohols, they usually end in the suffix all, as in sorbitol, xylitol, mannitol, and you see xylitol, mannitol, sorbitol, okay, here on that hidden list. Not that they're hidden, they're clearly there, but you might not be familiar with these sugar alcohol terms. They are put into a lot of your diabetic foods, or when you see a product, quote unquote, called sugar free. Okay. Food manufacturers really can be deceiving when they call a product, quote, sugar free, end quote, but yet it still has carbohydrate in it in the form of these sugar alcohols. And I cannot tell you how many times my diabetic patients would come in and say, oh, well, I'm not eating regular candy anymore. I'm eating sugar-free candy. And I would pull it up online, oh, well, what kind are you having? And then, talk to them about sugar alcohols and say, well, they still have carbohydrate. They still will raise your blood sugar. And it would blow their mind. So, and also another interesting fact about these sugar alcohols is because they are poorly absorbed, if you eat a high amount, and there again, it varies from person to person, but I have found that patients who eat more than about 10 to 15 grams of sugar alcohol at any given sitting, it can lead to diarrhea and stomach upset. You will find these sugar alcohols in sugar-free products, diabetic candies. So sugar-free chewing gums, sugar-free breath mints, sugar-free diabetic candies. Just know that sugar is only one type of carbohydrate. Okay. Then we get into what we call your non-nutritive sweeteners. So non-nutritive sweeteners, meaning they do not have calories. You may know them as your artificial sweeteners. These are substances that are going to be kind of divided into three categories. They're either going to be a chemical, they're going to be a mechanically or chemically altered sugar, or they are going to be a plant or an herb or a plant. So let's go through that real quick. They are very sweet, extremely sweet, ranging anywhere from 80 times sweeter than sucrose all the way up to 400 times greater than sucrose. So tremendously high. And but they are used quite frequently because they do not have calories, okay, and they do not have carbohydrate. So they are carbohydrate, sugar-free alternatives that still give you that sweet taste. So some are chemicals such as saccharin, aspartame, acesulfame K. Then you have some that are modified sugar, known as your sucralose here, that is your Splenda, meaning your body's not going to, it's sugar that's been modified to where your body doesn't digest it, you excrete it out. And then you have your plant-based sweeteners known as your stevias, your monk fruit. These are highly purified plants that have a sweet taste to them. Your textbook also gives a very good example here, comparison. So I do highly recommend you take a look at that. And they are regulated by the FDA, the USDA, and on the generally recognized as safe list for consumption. You see here on this diet Dr. Pepper caffeine-free can here, you see this phenylketone uric, okay, and this phenylalanines here. That is a breakdown of metabolism of aspartame. So because it is a chemical, any product with aspartame must have this warning label on it for people who cannot break down this phenylalanine, and they will end up with phenylketonuria, which is very alarming and can be serious. It's an inherited genetic disorder where they cannot break down this particular chemical. That's why it's a warning label on certain foods. Then we move to the second type of carbohydrate, and these are known as your complex carbohydrates. And there again, they are broken down into different types within that type. So you have complex carbohydrates, you have your polysaccharides and starch. So poly meaning many, okay, saccharide here meaning sugar. So this is where you have multiple monosaccharides bonded together to form a larger chain-like structure, as you see here. They are the storage form of energy in plants, and they are the structural component of stems and leaves of plants. And they are multiple monosaccharides bonded together. So here's an example. Your polysaccharides are eaten in the form of starch. Okay, these are your plant, your seeds, your roots, your tubers. So your starchy vegetables known as your potatoes, your corn, your peas, your legumes, okay, those kind of things. Notice how you have these dozens of glucose molecules chemically bonded together to form a polysaccharide. And this was the storage form of energy for the plant. When you get down here to glycogen is the storage form of these polysaccharides in animals. And yes, that includes us. So the term glycogen, glyco meaning sugar, gen meaning to generate or to create. This is how the body can store excess glucose as energy in your liver, primarily stored in the liver, and sometimes can be or is also stored in the muscle. This is also why you can go days, maybe weeks, or hours and days, excuse me, uh, fasting and not die, obviously, because you have storage, a form of energy in your body, in your muscles, and also in glycogen, and also as fat. Okay. Um, we'll talk about fat metabolism when we get to the fat chapter, but since we're here with carbohydrates, glycogen, the storage form of excess glucose. Well, some glucose. The liver can only hold so much glycogen, and the muscle can only hold so much glycogen. So it's not the end all be all storage form. Okay. But this is why when I said earlier how your body can create its own glucose, it does that here by breaking down glycogen. Then we have the next type of carbohydrate known as fiber. Okay. Fiber is a type of complex carbohydrate. And humans do not have all the enzymes needed to break down these very complex structures. So this is why we as humans cannot eat grass and hay and those kind of things like cows can, because we do not have those enzymes to break down those highly complex carbs. So there are two types of fiber. You have your soluble fiber and your insoluble fiber. This diagram here simply talks about how we can easily break down carbohydrates here. Okay, we can easily break down carbohydrates, but fiber is different. We do not have that intestinal enzyme to break these bonds. However, there is still some benefit to fiber. So let's talk about that. Soluble fiber is just that. It is soluble in water. So it delays stomach emptying, it slows glucose absorption, it can lower blood cholesterol to some extent because of its solubility. It has those types of physiological effects that can slow down uh, or can raise satiety, empty stomach, or delay stomach emptying, and does show a little benefit in lowering glucose absorption. You see soluble fibers in pectins, your gums, your beta glucans, and some of your hemicelluloses. So these are just different types of fiber. And you would find those in your food sources known as your apples, your bananas, your carrots, your food thickeners, those kind of things. So, yes, they can somewhat lower blood. Well, I don't want to say lower blood glucose, but they are absorbed more slowly. Let's put it that way. And they do help you to feel full. The second type of fiber is what we call insoluble fiber, and this is the part of the plant that we cannot digest. Okay, it is not dissolvable in water, and these are what we call your whole grains, as you see here, your brown rice, your whole wheat kernel, your whole grain foods, your wheat brands, that kind of thing. Your gut benefits from this fiber twofold, actually threefold. The first way is it helps to increase your fecal bulk, meaning if you remember back when we talked about the digestive system and the major function of your colon was to reabsorb water that up to that point had been needed for absorption. Once the food or chyme, as it's called, enters into the large intestine, very little nutrient absorption happens in the colon. Yes, there's some vitamins that are absorbed, but the main absorption here is water. And so fiber helps to increase that fecal bulk, helps to speed along that fecal material in the colon during the bowel movement as that fecal material is being moved through the colon, ascending, transverse, descending, that kind of thing throughout the whole GI tract there. and it leads to more comfortable bowel movements, meaning you're not constipated. So fiber is a good thing if if you are eating it in the whole food manner. Okay, remember way back on or in chapter 1, we talked about refinement and how food processing along the steps lead to less and less fiber. And you see a good example here. Okay, you see this whole apple, unpeeled apple, peel and all, is about 4 grams of fiber. When you take off the peel, okay, then and you puree just the apple flesh, that gives you apple sauce, and that is 2 grams of fiber. And then if you only juice the apple, you don't eat the peel, you don't eat the pulp, you only eat or only drink the juice, notice how you've gone down to less than half a gram of fiber. So this is where, as a dietitian, and especially a dietitian educating diabetics, I would always say, yikes, okay? This is a carbohydrate food, number one, that will raise your blood sugar in any form, but it's going to definitely raise your blood sugar quicker if you eat it in the more refined manner or structure. And half the time, they're going to add added sugars here to the applesauce and the apple juice. Okay. So you're drinking and eating twice the amount, if not more amount of sugar that's even naturally found in the food. But we're speaking about fiber here. So when you eat fiber, definitely do so in its whole form. The less refined, the better. So let's talk now about what happens to carbohydrate when it does enter the body and how it is absorbed. So when you consume carbohydrate, that actual breakdown of carbohydrate happens in the, begins in the mouth, okay, through this enzyme known as amylase. So your salivary amylase begins to digest some, break down, chemically digest some of that starch right there as you're chewing it. Okay. Once it enters the stomach, then you have stomach acids that take over. Okay. And begin to fully break down or begin to break down some of the foods that you're eating, the more complex proteins and fats, okay, those hydrochloric acids that are in the stomach. Then you have your small intestine, which is the main site for carbohydrate digestion and absorption, specifically in the jejunum, of the small intestine, that second portion there. You have these different types of enzymes. Remember, we spoke earlier about how enzymes are needed to break that chemical bond between your monosaccharides, your polysaccharides, and your complex carbs and so forth. So you have a variety of enzymes here. You have your pancreatic amylase, which is made in the pancreas. You have maltase, you have sucrase, lactase, all of these enzymes that help to break down these specific bonds. Once that's done, these simple carbs can then enter into the bloodstream and be transported throughout the body. But remember earlier we talked about how the liver does receive glucose, can store glucose in the form of glycogen, and that oftentimes can lead to some issues if the person or if they have excessive carbohydrate intake, excessive sugar intake. And we're going to be talking about that a little bit later when we learn about fatty liver disease, non-alcoholic fatty liver disease. And I think we're going to finish with that later on. So Where there is glucose, there oftentimes is fat. And so we're going to combine or look at that a little bit more closer here before we finish up. But just know the liver has an integral role here in carbohydrate digestion. Your large intestine is where fiber is going to, like we said earlier, maintain bulk stability of fecal matter. It is also where certain celluloses from the plant, certain fibers are fermented in the large intestine and help to nourish and feed that good colonic gut flora, those good colonic bacteria that we talked about earlier. And then, of course, carbohydrate is then finally excreted through the rectum, in the form of your undigested fiber. Okay, very little dietary fiber is eliminated in the waste. It is going to be all absorbed or stored in the liver as glycogen or stored in the body as fat. Okay, or turned into fat in the body. Um, So you see that process here. Goes into the mouth as starch, activated, or it's full, continued to be broken down here in the stomach, absorbed here in the small intestine. Glucose, fructose, and galactose here are absorbed by the intestinal cells and then transported to the liver via the hepatic portal vein, and it converts that fructose into galactose and lactose. So the liver does have an integral role in some of this breaking down of carbohydrate, soluble fibers in the colon, and then bulk feces excreted in the rectum, through the rectum. Herein lies the um, uh, the hormone insulin. Okay. And the reason why I kind of hesitate here with insulin is, well, I don't hesitate, but this is, let me rephrase. Insulin is a hormone and it is needed. It is integral in glucose metabolism. Okay. Once glucose is absorbed, okay, so right here, once glucose is absorbed in the small intestine and it enters into the bloodstream, that glucose needs to enter the cells. Okay, we talked about how glucose is used as energy for the cells. Insulin is made, produced in your pancreas through these specialized cells called your beta cells. And insulin has multiple functions. Helping glucose enter the bloodstream is only one of those functions. The second function here is that it stimulates the storage of glucose as glycogen in the liver, so it has that liver effect. It also promotes fat and protein synthesis. Okay, so in other words, it helps to store fat. It is a temporary decrease of hunger because with it being a hormone, it's going to affect satiety. But I want to make sure people understand, and I tell my diabetic patients this as well, and my overweight and obese patients, that the higher your insulin level, the higher or the higher your insulin level, the higher your liver is going to be working, and the more fat you're going to possibly put on. Okay. So it's an integral dance when we look at the cycle here of maintaining normal blood glucose. So this is what we're going to be focusing on when we get to part 2, which is talking about diabetes. All right. A normal healthy blood sugar around 70 to 99 milligrams per deciliter. That is someone without diabetes. Okay. They eat carbohydrates, the blood glucose is going to rise. Their pancreas has to kick in and has to secrete insulin in order to get that glucose in the cells. Insulin stimulates the liver to take any excess glucose, or well, not all of it, but some of that excess glucose, and turn it into storage form of glycogen. Okay. After a few hours after you eat, your blood glucose begins to drop. You begin to feel hungry again. If you don't eat, then your pancreas has to release glucagon, which is the hormone that is going to cause your liver to release that glycogen so you can add more blood glucose to your bloodstream and maintain your blood glucose until eventually you do eat. Okay. And then the cycle continues. So, all in all, this is an intricate dance, okay? And it is a lot more complicated than you think when in a normal metabolic person. But throw in somebody who has diabetes where their pancreas isn't making quite enough insulin, somebody with non-alcoholic fatty liver disease, and it really does complicate things. But we can go down that rabbit hole a different day. So glucagon, okay, I mentioned glucagon right here, but we didn't really talk about it yet. Glucagon is the alternate hormone to insulin. So if insulin makes your blood sugar go down, which it does, then glucagon makes your blood sugar go up, or it helps to regulate your blood glucose by increasing your blood glucose by glycogenolysis, meaning breaking down this glycogen that is stored in the liver. It can also regulate your blood glucose levels through lipolysis, the breaking down of your triglycerides of certain fats into glycerols and fatty acids that the body can then turn into glucose. Okay. So it's all part of that your body's regulation of maintaining homeostasis. Okay, the body really wants to maintain a normal blood sugar whenever possible. Your body, or excuse me, glucose can and is used for energy. Okay, the cells use oxygen to release energy that is stored in glucose. The byproduct of that is your carbon dioxide and water. It is and can be used as the primary fuel for the body cells. Not all, I mean, your body can also use ketones and does successfully. We'll talk about that next slide. But glucose is the primary fuel for body cells. Okay, some cells can only use glucose for fuel. And you see that breakdown here. We mentioned earlier, or just a minute ago, ketones. Ketones are one of the metabolic, or what's left over, or the result, excuse me, of the breakdown of fat or the burning of fat. Okay. When glucose is not readily available, and when people are either purposefully fasting or purposefully trying to go into a ketosis state, such as in a very low carbohydrate diet, as in a ketogenic diet or an Atkins diet, the body switches from using glucose as its main energy source to using ketones through its main energy source. Okay. Your brain and muscles do love ketones. The brain actually runs very well on ketones. And there are certain neurological diseases where people who have certain seizure or seizure disorders specifically are put on a ketogenic diet to have the brain run on ketones instead of glucose. So but that's under the supervision of a doctor and under the supervision of a dietitian to make sure they're getting their energy needs. But it is possible. So having the body run on ketones can be beneficial for certain people. And we do see results of burning fat and weight loss on ketogenic and Atkins type diets. I do want to stress, though, that a ketogenic diet and having the body run on ketones is completely different, okay, than this uh, disease here called ketoacidosis, okay? When blood ketones are anywhere from maybe a 0.5 to going on about 3, um, you're fine. Where we get into trouble and where it can become deadly is when people who are type 1 diabetics, their ketones rise way above this ketogenic level, and where the body becomes, or excuse me, the blood becomes acidic. Okay, the pH of the blood rises, and that can be deadly. Okay, but they are two very different uh, two very different conditions that sound very similar. Okay, ketogenic is very different from ketoacidosis, so just be aware of that um, when you are studying ketones and looking at low carbohydrate diets. Okay, ketoacidosis occurs in poorly controlled type 1 diabetics. Okay, not the same as up above. When we look at using glucose for energy, the recommended daily allowance of glucose is 130 grams per day to prevent ketosis. So there again, that is not ketoacidosis. That's this here, okay, ketosis. And there again, that varies. I've had patients go into ketosis. Oh, excuse me. Yeah, this is to prevent ketosis. Yep, that's true. Under starvation conditions, the body uses amino acids and skeletal muscle to form glucose production. That is under starvation conditions. Okay, so that's when the body is lacking in overall energy. Okay, not just one certain macronutrient. So then we look at carbohydrate consumption patterns. This is a diagram talking or from the old dietary guidelines. Because remember, the 2025 dietary guidelines were just released, like right after this class started this semester. So it's kind of changed a little bit, but the average, okay, recommendation is to get a little bit less than half of your energy from carbohydrates. And actually, that with the new dietary guidelines, the 2026 dietary guidelines that just came out mid-January 2026, that's now even less. Okay. And no more than 10% of your total calories should come from added sugars. Actually, I try to tell my patients, or I do tell my patients, have that be 0 if at all possible. And how do we do that? We do that by not drinking your sugar. Okay, don't drink it in the form of soft drinks. And try to definitely avoid fruit juice or juice drinks, different types of syrups in your beverages, your coffees, that kind of thing. Eat your foods whole. Okay, try to avoid highly processed foods And of course, your added sugars are going to be your candies, your cakes, your sweets, your desserts, all of those that do have added sugar. So how do we know what we're eating? You know what you're eating by looking at the nutrition facts label, as you see here. The nutrition facts label is found on every food, and by law, they give you the total total carbohydrates here, okay, because this chapter is focusing on carbohydrates. So this total carbohydrate by law only needs to list, however, fibers, total sugars, and added sugars. Okay. Notice how it does not always add up, right? You have total sugars, which is 11 grams. 11 does not equal 24. Okay, so what happened to the remaining grams of carbohydrate here? Well, they are in the form of starch. So that's why you really look at both numbers. I tell my patients to look at this total carbohydrate number. Okay, and that's per serving, by the way. Okay, so for these 5 cookies, you're getting 24 grams of carbohydrate. And of that 24, about half of it, okay, a little less than half, is in the form of added sugars. Okay, which makes sense because it's a cookie. It also makes sense when you look down here and look at the ingredients on the label. So let's real quick go through these and try to find, all of the carbohydrates. So flour, yes, that is a carbohydrate. Sugar, yes, that is a carbohydrate. Dextrose, yes, that's a carbohydrate. Sugar, yes, that's a carbohydrate. Cornstarch, yes, starch, that's a carbohydrate. Whey, yes, that's a carbohydrate. Corn syrup, yes, that's a carbohydrate. Salt, no. Natural and artificial flavors, usually those are chemicals, okay? We don't know what the natural flavor is. Milk, yes, that's a carbohydrate. Non-fat milk, yes, that's a carbohydrate, okay? So out of these ingredients, most of them were carbohydrates. So as we look and go throughout the semester, definitely focus on the total carbohydrate number and the added sugar number and try to make sure that these two are as low as possible. And if you are going to eat a carbohydrate, then make sure it is in the form of a complex carbohydrate with as few total added sugars as possible. Okay. This is another example here. So wheat, flour, yes, that's a carbohydrate. Brown sugar, yes. Wheat, gluten, yes. Cracked wheat, yes. Wheat bran, yes. Molasses, yes. Okay. Milk, yes. All right. So really start looking at your food labels and paying attention to what you are eating. And I wanted to end here by looking at how carbohydrates affect our health. We're going to dive into the diabetes portion next video. But carbohydrates do lead to tooth decay because they are the simple sugars especially are sticky. Think of your honeys and your molasses and how they stick. Good dental hygiene, you can lead to bacteria on your teeth, and there is a strong linkage between oral health and your risk of heart disease, between oral health and diabetes management. There is this one right here. This is the $1,000,000 question, isn't it? Do carbohydrates make you fat? Okay, or do they have you cause weight? Or gain weight. Just know that Yes, calories in, calories out. Okay. But that's strictly by numbers. If those calories are not used as energy, then the body has to do something with that energy. Okay. No matter what form it takes. And we know that insulin, remember we talked about how if your insulin is high, how that can promote fat storage. So the more carbohydrates that a person eats, especially in the form of ultra high processed foods, they are more likely to gain weight and be obese. The more carbohydrates you eat, the more your blood glucose goes up, the higher your insulin level is, no matter whether or not you have diabetes. Okay. Um, and that can be associated with weight gain. Foods that contain very large amounts of refined carbohydrates, meaning those ultra high processed carbs, they do not satisfy your hunger because they do not have that fiber. So it goes back to that cycle where you get up in the morning, you eat the milk and the Pop-Tart. 2 hours later, you're starving. So you grab a candy bar and some French fries. 2 hours later, you're hungry again. So you grab a peanut butter and jelly sandwich and maybe a side salad. 2 hours later, again, you're hungry. You see what I mean? All of those are examples of refined carbohydrates that will not satisfy your hunger, okay? Because they are high carbs and not enough protein and not enough fat and not enough fiber. So, and this last statement here, excessive carbohydrates are more likely to be burned for energy than fat, and that's true, okay? So the carbohydrate spares the body from fat being burned as fuel. But go back to up here, okay? If you are an obese person and you have excess fat to burn and you are wanting to lose fat, then we want to find a way that our body can use our excess stored fat and instead of running on carbs, if that makes sense. Okay. And then lastly, when we look at your non-alcoholic fatty liver disease, excessive carbohydrates do get converted into fats, and that's part of what can lead to this particular liver disease. Leads to an abnormal accumulation of fat in the liver, not associated with alcohol. Okay, remember alcohol is metabolized in the liver, but this is not associated with that. These fatty deposits do damage the liver cells, causing inflammation, and that means the liver cannot filter the blood properly and can lead to scarring known as cirrhosis of the liver. The main risk factors in this non-alcoholic fatty liver disease is obesity. Okay. And for someone who is going to be obese, which means they probably have been taking an excess amount of carbohydrate, and they're not able to maintain their blood glucose due to being insulin resistant. Okay, excessive carbohydrate intake here. So it goes back to that cycle that we talked about earlier. So prevention, prevention, prevention. Eat a healthy, well-balanced diet, low in added sugars, low to moderate in carbohydrates, and avoid alcohol. Making sure you get enough protein and healthy fats, which we'll talk about protein and healthy fats in our other chapters. Okay. So we will end there because diabetes is a whole nother, topic, which we will focus on next time. Thank you.